Helicopters are amazing machines. Unlike airplanes, they can take off straight up. They can hover in the air like a hummingbird. They can even fly backwards. But how do they do it? What makes helicopters different? The secret lies in their rotating wings called rotor blades. These blades are long and curved like the wings of a bird. As the blades spin, they create a force called lift. This lift is what allows helicopters to defy gravity. Imagine holding a piece of paper and blowing air over its top. You'll notice the paper rises. This is a simple demonstration of lift. The faster the air moves over a surface, the lower the air pressure becomes above that surface. Helicopter blades work in a similar way. As the rotor blades spin, they force air downwards. This creates a difference in air pressure. Lower pressure above the blades and higher pressure below. This pressure difference generates lift, pushing the helicopter upwards. The amount of lift generated by the rotor blades depends on their angle of attack. This is the angle at which the blades meet the oncoming air. A higher angle of attack means more lift, but also more drag. Pilots can adjust the angle of attack of the rotor blades to control the helicopter's altitude. Increasing the angle of attack generates more lift, causing the helicopter to climb. Decreasing the angle of attack reduces lift, allowing the helicopter to descend. We've seen how helicopters generate lift to overcome gravity, but how do they move forward, backward, or sideways? This is where thrust comes in. Thrust is the force that propels a helicopter in a desired direction. By tilting the rotor disc, the pilot can direct the lift force, creating thrust. Tilting the rotor disc forward directs the lift force forward, propelling the helicopter forward. Similarly, tilting the rotor disc backward, left, or right generates thrust in those directions. Section 5. Beating the air into submission, the power of torque. Every action has an equal and opposite reaction. This is Newton's third law of motion, and it plays a crucial role in helicopter flight. As the engine spins the rotor blades in one direction, it creates a twisting force in the opposite direction. This twisting force is called torque. Imagine trying to spin a wheel in one direction. You'll feel a force pushing back in the opposite direction. This is torque in action. In helicopters, torque would cause the helicopter's body to spin uncontrollably if left unchecked. Section 6. Taming the spin, the tail rotor's balancing act. To counteract torque and maintain stability, helicopters have a tail rotor. The tail rotor is a smaller set of blades mounted vertically on the tail boom. It acts as a mini propeller, generating a horizontal thrust that counteracts the torque from the main rotor. By adjusting the thrust of the tail rotor, the pilot can control the helicopter's yaw, which is its rotation around the vertical axis. Increasing tail rotor thrust counteracts more torque, turning the helicopter to the right. Decreasing tail rotor thrust allows some torque to affect the helicopter, turning it to the left. Section 7. The dance of controls, pitch, roll, and yaw. Helicopters have three basic control inputs: pitch, roll, and yaw. Pitch refers to the helicopter's nose-up or nose-down movement. Roll refers to the tilting of the helicopter from side to side. Yaw, as mentioned earlier, is the rotation around the vertical axis. Pilots control these movements by changing the pitch of the main rotor blades at different points in their rotation cycle. This is achieved using a complex system of swash plates, linkages, and hydraulics that allow for precise control of the rotor blade's angle of attack. Section 8. Helicopters, versatile machines for every occasion. Helicopters are incredibly versatile machines. They can perform tasks that are impossible for other aircraft. Their ability to take off and land vertically makes them ideal for operating in tight spaces such as urban areas or disaster zones. Helicopters play vital roles in various sectors, including transportation, emergency services, construction, and military operations. They transport passengers and cargo, fight fires, assist in search and rescue missions, erect power lines, and provide aerial surveillance. Section 9. The future is up and away. Helicopters in the 21st century. As technology advances, we can expect even more innovative helicopter designs and applications. Engineers are constantly working on improving helicopter efficiency, safety, and capabilities. From electric helicopters with reduced noise and emissions to autonomous helicopters for complex tasks, the future of vertical flight is full of exciting possibilities. Understanding the physics behind helicopters is essential for unlocking these advancements and expanding the horizons of aviation.